Okay, welcome back to our DR103 clone build here, otherwise known as the HIWATT DR103. On this section, we're going to be working on the preamp section right here. Now, I'm using the original early 70s 4-input preamp schematic from the HIWATT.org site. So to build this preamp board using the Mojo Tone turret board here, we're also going to be using some 18 gauge barrel wire and then some 18 gauge green wire for a lot of the longer runs to keep them insulated and out of mischief there. Now, if you look at a couple of other diagrams here from the Mark Huss site or the HIWATT.org site, we have the preamp board layout right here, and you can see the little dotted lines showing where all the strapping or connection points between the turrets are. But I'm also going to bounce that against the Seratone schematic that has the same thing. Okay, as you can see, we have the jumpers or strapping done on the turret board. All looks pretty good. Didn't do too bad of a job. I guess I'm getting a little better as this project moves along. Anyway, again, we're doing the 70s 4-input preamp, which is this one right here. Now, to make this easier, we do have the layout, again, from the Mark Huss site, HIWATT.org. Here are how the components are laid out. But I'm going to cross-check that with the schematic as I add a couple of components. We'll refer back to the schematic just to make sure that it lines up with what the schematic says. Plus, as I add the components, we're going to be checking them with a meter before I install them, the capacitors and the resistors. So between all these checks, I think I'll do probably a 99% chance of getting this correct. But if not, that's part of the deal, and we'll troubleshoot and get her fixed. Okay, we're going to start populating the preamp turret board here. Go down the line like this. Our first two components are a 2.2K resistor and a, let's see here, what is this one? 0.047 microfarad capacitor. Now this layout is from the HIWATT site, but we cross-check it against Seratone. Now Seratone uses a 1.5K resistor right there. So I've got one of those too, and I don't know what the benefit of that mod is, but we may go ahead and change it out and just see what it sounds like. Here we have 2.15, so that's within tolerance. We can also check the capacitor with this meter. Let's go to our capacitor checker. And we have 45 microfarads, supposed to be 47, but probably within tolerance. Ah, look at that, 45.8. May take a minute for this to charge and read. And this little meter probably isn't the highest calibration, so close enough. Made this little tool here. And this is a centering tool for cutting the leads, and how this works is you put your component in there, center it, and then if you cut the leads right at the edge here, you get the perfect length, hopefully, for the turret board. Yeah, there you go. You can see these leads are long enough to get their bend and go down into the turret. So pretty cool little tool, takes the guesswork out of how to cut the leads. And away we go. Okay, we got our two first components in. These go to the cathode of V3. These connect up there, and you can see right there, hopefully, we'll zoom in, but the 47 and the 22.2K going to ground. Now ground is going to be this bus right here, but they're strapped together on the other side as well. So this will go to the cathode of V3. And we're going to repeat this process across the board, check our layout, check our component values, and then check against the schematic as we go along. Okay, we got our preamp board completed here. I'm pretty happy with the way it came out, nice and shiny and new, and I'm 99% sure everything is connected properly. So next we're going to go ahead and run our heater wires, or filament wires, from where it attaches to the first PA tube, and then we will run it down these preamp tube sockets that I just installed. Okay, we got our heater or filament connections done up here. I had to use the old wires and the hand drill method to get them twisted nicely. Used 2 different colors so that I could keep the phases correct. I'm trying anything I can do to keep the noise down, and they tap in right there where the filaments go to the power tubes. So all in all, pretty good, and I know they're going to be good because I get 6.6 volts at the last tube here. So if it's good there, I know it's good all the way across. So next thing is to complete the tone stack and the preamp board. Okay, as you can see, I've got the input jacks completed. I went ahead and used this alternate diagram or another modded configuration here. Instead of having 2 normal and brilliant jacks, you know, like in the regular 4 input HIWATTs, this diagram tells you how to do a linked, because everybody knows if you have the 4 input, you're going to be using a Y cable to hit both sides of that tube at the same time for a little more presence and gain and all that. So anywho, this way you don't need the Y cable. You plug into this one here, and this is the back side, by the way, in case you want to replicate this. So this is the back side of the jacks. Now this is kind of hard to do if it's in the chassis the normal way. So what I did was went ahead and plugged them in the opposite way, backwards, to get this wired up, and then you take it out and then put it the right direction. Much easier, including your input coax. Okay, you can see we got our input jacks installed. I've got the audio coax that come from the jacks to our first tube. I haven't terminated that yet or soldered those on. We did get the preamp board installed. We got 1 pot installed because it had 1 connection that ran underneath the board to this tube here, and I wanted to do that before I put the board in. But it's coming along pretty good. It's a little tight now, working in here, as you can imagine. So we got our input leads attached to the power amp section. These are audio coax that come underneath and then connect to the, see if I can do this here, connect to the preamp board outputs right here. And then we got our B plus for the preamp tubes right here running underneath, attaching there. So all in all, we're doing pretty good. Next, we're going to start adding in our potentiometers and wiring up the tubes and the rest of the board. We're moving right along here. One thing I noticed was when you put the potentiometer in first and then try to solder the components and into the board, it's a lot harder than if you just solder the components on before you install the potentiometer. These are the ones that are attaching directly to the leads of the potentiometer. So for the rest of the build, that's what I'll be doing. But we're moving right along. We're going to go ahead and wire up our potentiometers across here first, and then we'll come back and then wire in our preamp tubes, and then that'll be it. So stand by for fun. Stand by for fun! Okay, we've got our potentiometers installed. Came out pretty good. I can't express enough the importance to get these leads and components on that connect directly to the potentiometers on before you put the potentiometers in the chassis. Okay, and we are done, at least with the major assembly here. Got all the preamp tubes wired in. I guess my soldering got a little better as time went on through this project. If I had to do it all again, as I've said before, it would be much neater. So now, before we go plug it up and bake in the tubes, we're gonna do some quality assurance, quality control. I'm gonna go through with some magnifying glasses and check all of these solder joints here. Another thing you gotta check for is on these pots, you want to make sure the terminals at the bottom aren't shorting against the chassis, because sometimes during installation they can move or solder could get in there and short that out. So we're going to take a wooden stick and make sure there's a gap between all 3 terminals, you know, a gap between the 3 terminals on each pot and the chassis to make sure that's clear. And then we're going to go ahead and clean her up with some isopropyl alcohol. And then finally, we'll get on the air compressor and blow out, hopefully blow out all the small debris from assembly, little tiny bits of wire or insulation that may have wedged themselves where they're not supposed to be. And then after that, we're going to take her upstairs and plug her in and hope for the best. If your lights flicker and power goes out in the city you're in, this may be the cause. All right. Okay, so far so good. We got power on, got our speaker hooked up, 16 ohms. We got filaments. Checked one of the preamp tubes. There's filaments there because I pretty much believe if there's one there, there's one everywhere. So we're gonna let this bake in for 10-15 minutes before we turn on standby. Normal channel, all controls mid-range, very clean. Bright channel does not work. So bright channel not working, we'll have to troubleshoot that. This proves the tone stack is working. Just probably got something in the wiring and the jacks as the issue with the bright channel. This fucker's loud. HIWATT DR103 test with an OCD at all mid-level. Sounds pretty good. Okay, the HIWATT 103 finally started working. I had to replace the V3 tube socket. For some reason, the pins wouldn't go in all the way, so I wasn't getting the full signal through the tube right there. I do not have the bright channel working, but I've isolated it down to probably just the jacks. I'll have to see what's going on there. Could be in the wiring configuration I got for the linked input. Either way, that should be something simple to fix. Got it biased right, 35 milliamps at the test points. Took a while for that to stabilize, but all good. Even threw a fuzz box on it, as you heard. So anyway, I think we're heading the right path. I'm clear now to go ahead and order the head shell and the faceplate so we can get this prettied up. But we'll take it up to Austin so my friend Shay can really check it out against his arsenal, as it were, of different amps. So anyway, a fun project. It's coming to a close. I may play around with, if it starts to sound too harsh, one of the reasons could be I use precision metallic film resistors in the tone stack. So I may go ahead and swap those out with traditional carbon resistors. They say that kind of helps the tone a little bit, but we'll see. You know, everybody's got an opinion based on what they hear, so I'm not going to tear it up too much beyond what I've already done. Stay tuned for part 4, the full demo.